Okay, so we're going to do another quick review here on the chi-square. In this case, we're looking at two plants that I found along the snake den branch. The two plants are a flowering nedge and a wild mint. And we looked at 150 different quadrat samples, and these are the results that we found. In 25 cases, we found that both the flowering nedge and wild mint were present. In 45 cases, we found only wild mint. In 30 cases, we found only the flowering nedge. And in 50 cases, we found neither of the two plant species present. So I've filled out my observed data here, and what we're going to try and do is to see if there is an association between the flowering nedge and the wild mint. We're going to need our null hypothesis, and the null is going to be stated as there is no association between the two. And I'm going to abbreviate my wild mint, WM, and my flowering nedge as FN. Okay, so no association between these two. So we have our observed, and now we need to calculate our expected. And to get our expected, we're going to take the totals that we have to do here. So 45 and 25 is going to give us 70. 50 and 30 will give us 80. We had 150 total. We talked about that. This is 95, and 30 and 25 gets us 55. Okay. To get our expected, we take a row total, which is 70, and then we're going to multiply that by a column total at 55 and divide by 150, and that'll give us our expected value for both. So 70 times 55 divided by 150 is going to give us 25.7. These totals will always be the same as our observed. Okay. So to get our expected when there's wild mint absent but flowering nedge present, again we had 70, and then we have, in this case, our column 70 times 95, and then we divide that by our grand total of 55, and we get a number here of 44.3. And if we added both of these up, we should get back to 70. Okay, so to get the flowering nedge absent and the wild mint present, we could take 55 and subtract 25.7. That would give us a value here of 29.3. Okay. And again, we could do the simple subtraction, 95 minus 44.3 to get this value. But again, I'll take you through the math. We have 80 times 95 divided by 150, and that'll get us 50.7. So here's our expected values, and here are our observed values. We're going to use that to calculate our chi-square. I'm going to fill this table in real quick. Okay, so I subtracted my observed from my expected, and then I squared that to get 0.49. And then we're going to take 0.49 and divide it by 25.7, and then we're going to get our value here of 0.019. Okay, 0.49 divided by my expected value of 29.3 is going to give us 0.016. 0.49 divided by 0.49 divided by 44.3 will give us 0.011, and then 0.49 divided by 50.7 will give us a value of 0.009. Okay, so here we have these. We're going to total these, so we're going to sum at the bottom, and we're going to get a total of, this is our chi-square, is the sum of that, and that's going to be 0.056. Okay, and now for the good news. The good news is, in any test that you're going to get for IB, this value is going to have to be given to you. So all of these calculations are just practice. So given our data set, the fact that we have 2 rows and 2 columns, and we have a given chi-square value, what we really need to be able to do is figure out what the degrees of freedom are, and then based off that degree of freedom, go in and get the critical value from a chart and compare our critical value to our chi-square value. Okay, so number of rows, we have 2 rows of data, and we have 2 columns of data, which gives us 2 minus 1, so 2 rows minus 1, times 2 columns minus 1, equals 1 times 1, which is 1 degree of freedom. Okay? And with 1 degree of freedom, we go back into the chart that we're given. And again, this is our standard here, this 0.05%. And if we look in this chart at 0.05%, at 1 degree of freedom here, we have our critical value of 3.84. That's what we're going to compare our chi-square value to. Okay, so given our chi-square value that we found, okay, our critical value is 3.84. Okay, and what we said earlier when we talked about the chi-square is if the chi-square is less than the critical value, then we're going to accept the null. So 0.056 is less than 3.84, and because of that, therefore, we're going to have to accept the null. And what the null says is that there is no association between the wild mint and the flowering edge. So we're going to accept that, and what we're going to say is, in conclusion, there's no association between the two. And what that means is anytime we get something that's what we think is close to expected, it's really just due to random chance. So, okay, and then we can justify this because our chi-square value is less than our critical value. So we come to a conclusion, and we've justified it with statistical analysis. That's the skill that you're going to really need for your test. Given a chi-square value, can you pull the degree? Can you get the degrees of freedom from the data type table, get the correct value out of the chart, and properly apply the idea that the chi-square calculated is less than the critical, therefore accept the null.